I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, January 19th. Tonight we'll be discussing jet stream level winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean, and of course our usual look at the snow forecast for the Northwest Pacific and down into California. Let's get to work. Looking at significant wave heights for the North Pacific Ocean, we see a much improved pattern. There's a gale in the Gulf of Alaska producing about 35-foot seas, and a stronger gale approaching the dateline with nearly 40-foot seas, and this is part of a building pattern of gales that are expected to be traversing the North Pacific in the weeks ahead. So, we're in a good place. Let's get into the details. First off, take a look at the jet stream. The jet stream is up about 30,000 feet. Winds in this area help support gale formation, help direct their track. What we're looking for is a trough, a dip in the jet, sort of like there is there, and sort of like there is there. What that helps do is create a counterclockwise flow aloft and at the ocean surface, and that, of course, is the hallmark of low pressure, counterclockwise winds at the ocean surface. And, of course, if the gale or the low is strong enough, it can create seas, and seas, as they radiate away from the fetch area, turn into swell, and swell, when it hits your beach, turns into surf. So we have a little trough off the Kuril Islands being fed by 150 knot winds, another trough in the northern Gulf of Alaska being fed by about 130 knot winds, offering some support for gale development. So, not a bad pattern. And the even better part is the jet is completely consolidated in the west, pushing to the dateline. The pattern the past 3 or 4 weeks has been the jet just massively split in the east and even back west of the dateline. But now we get the sense that the jet is consolidating, it's getting more energetic, and it's pushing off to the east. That's exactly what we want. So we put this into motion. We see as we get into Monday night, more of the same, jet building to the east. The little trough continues here in the Gulf. The trough over the dateline, maybe not so much. And we move into Tuesday, and then things start getting kind of interesting. The jet's still quite solid with, 170 knot winds feeding it. Trough setting up in the Gulf, trough setting up off the Kuril Islands, and only amplifying as we get into Wednesday. Then Thursday, a broad trough. Now, this is not deep. It's just broad sets up, and notice the jet completely consolidated to a point just off the California coast, looking pretty good. So we get into Friday, more of the same. Now, not super energetic and no clearly defined big troughs, but just a general pattern, very supportive of gale development. Notice as we get into Saturday, the jet actually pushes onshore into California, probably some weather there into Sunday. And basically, it holds as we get into Sunday and Monday with more energy building off the Japan coast, pushing over the dateline. A little bit of a split possibly setting up here, but again, a trough in the northern Gulf. So let's take a look at the effect of the jet on the atmosphere down at the surface, okay? We're looking for low pressure systems. We knew we had a trough right in here. We knew we had a trough there. Sure enough, low pressure system for sure. The one in the Gulf as of Sunday evening with 45 knot northwest winds over a tiny area, generating some seas, we're sure, and a broader, much broader gale on the dateline with 40 knot winds aimed off to the east, also getting traction on the ocean surface. Put this into motion on Monday. The Gulf trough or the Gulf low starts moving into, we'll say, Pacific Northwest, while the dateline gale looks quite solid indeed. 40 knot winds over a broad area aimed east. That's a pretty good pattern. And then right behind it, another system starting to develop off the Kuril Islands on Tuesday night. This is great. I mean, look at this. Almost the entire North Pacific filled with some sort of storm or gale activity. So we're into Wednesday morning. The gale over in the, we'll call it the Western Gulf, starts fading out. Strong system starts developing just west of the dateline. 50 knot northwest northwest winds, continuing into Wednesday night, fading some with 45 to 50 knot winds, pushing over the date line, still holding as we get into Thursday. Then that system starts fading out a little bit. We know the jet stream starts fading about that time as well, but not completely out. As we get into Saturday, things take a little bit of a breather, but you get the sense it's only a short breather, and all of a sudden you see 1, 2, 3 fetch areas, all with 30, 35 knot winds, almost the whole way from the Kuril Islands to the Eastern Gulf, some sort of fetch in play. Just continues into Sunday, and where are we here? Now it sort of consolidates, a decent gale pushing over the date line with 40 knot west winds, not huge, not large, but still doing something. That fades out, moves into the Gulf on Monday, and a new system theoretically building on the date line at that time. So, a very active pattern forecast for the next week. Let's go take a look at what effect those winds will have on the ocean surface. So first off, we're going to go back in time just a little bit to Thursday night, Friday. Small gale was in the Gulf of Alaska. This system pushed east and has produced swell that has already hit California. What we're really interested in is the system developing on the North Dateline region on Friday. It built with up to 30-foot seas midday Friday, pushing up to, here's max seas over the entire domain, 37-foot seas. We'll give it 36, probably, right in this area. Falling north-southeast, continuing into Saturday with 36-foot seas, fading into Sunday. Swell from this, and then it redeveloped a secondary system built. Also notice the system developing off of Japan at the same time with 39-foot seas. And then so the system in the Gulf redeveloped with 30-foot seas pushing east into current time, Sunday evening, with 32, 34-foot seas there, and our system on the date line. So another swell is pushing towards Hawaii. It's actually hitting as of, supposed to hit as of Monday morning, and pushing towards California with more behind it. So looking at the forecast models, all right, our little system continues. The reformed system continues in the Gulf. Our larger system approaching the date line on Monday morning with 42-foot seas, aimed east. Good little bit of swell that should be able to generate some 20-second period from that. System dying off of the California coast. Swell arrival expected on Tuesday. Another system building, or the system crossing the date line, starting to fade now. Still looking quite solid. It makes it to the, we'll say the Western Gulf on Wednesday before it starts to die out. You see the swell from it, the front just about hitting Hawaii in the evening on Wednesday, and another system building over the date line. This for Wednesday evening into Thursday. So the previous runs of the models had this really kind of blowing up. Now the 06Z run Monday, which is Sunday night, is fading some, not looking as strong. Still 44-foot seas, good enough to produce some long period swell radiating towards Hawaii and the U.S. West Coast. Pushes over the date line on Thursday and fades out on Friday. So then we know the jet stream kind of not falls apart, but weakens, and you can see it. Yes, 30-foot seas in the Gulf of Alaska on Saturday, and another fragment or another small gale with 32-foot seas pushing over up to 35-foot seas on Sunday and building to the 36, 37-foot range. So more swell from that expected, and we're 180 hours out. So you see it's just gale after gale after gale, and even when they're not big organized gales, there's still multiple. So it looks like a long run of continuous swell is on the charts. Nothing particularly huge, but steady nonstop surf, potentially a week worth of nonstop waves. This is where we want to be, and we all know why that's happening. The long-awaited active phase of the MJO. We'll get into that in a little bit. All right, so what are the winds going to be like? The good news is the nuking trades that have been howling over Hawaii have finally settled down with more low pressure in the northern Gulf. That's cut out. High pressure is what drives the trades, right? And now we're down to a 1024 millibar high. I think last week when we did this, the high pressure was a 1041 millibar high, completely filling the Gulf of Alaska, just raking east winds across the islands, north winds down the California coast. The active phase of the Mjo is in control. That pretty much just stomps on high pressure. It feeds the jet stream. Remember, we talk about the active phase, or the Mjo, when in the active phase, it feeds energy to the jet stream. The jet stream starts building, pushing to the east. That kills high pressure. It feeds the storm track, feeds low pressure development. This run that we're on in the models right now is a classic example of the active phase of the Mjo doing its magic in the North Pacific in winter months. All right, so we have low pressure in the Gulf of Alaska, but we have a light offshore flow. Let's move into Monday. Here we go. Monday morning, light flow along the California coast. Trades for Hawaii, but nothing nuking. 15 knots. Pretty much a normal sort of thing. And then a front starts building off the California coast. South winds take over for Northern California Monday night as we get into Tuesday. Trades continue for the Hawaiian Islands, but not a strong front. South winds in the 15 knot range, for 20 knots for Northern California, down into Southern California. So Tuesday is kind of a south wind mess north of Point Conception, but not horrible. Light trades almost turning south for Hawaii. Looks like a front getting ready to move over that area. As we get into Wednesday, southeast winds, light for the Hawaiian Islands. Light south flow for Wednesday for California, north of the Golden Gate, but maybe south of there, just a light, generally light winds. Get into Thursday, more of the same, light winds. Winds south for the Hawaiian Islands, very light, low pressure moving very near, almost, look at that, as we get into Thursday night. Looks like a southwest flow starting to set up. Light winds for the California coast. Building into Friday, sort of a northwest flow for Point Conception. South winds north of there. The Golden Gate is the dividing line. Light winds in the Hawaiian Islands. We get into Saturday. Looks like a gale trying to consolidate in the Gulf. South winds, again, the dividing line looks like the Golden Gate for California. Trade setting up for Hawaii. Let's put this into motion. Again, a front along Northern California coast. We get into Sunday, kind of looks like a south wind mess north of Point Conception. Trades continue for the Hawaiian Islands. We'll go into where we get to Monday. High pressure sets up, light winds, light trades for the Hawaiian Islands, and sort of a northwest flow setting up for, we'll call it Central California, much lighter for Northern California. So it looks like the deal is California is this, you got to play the game of in between the fronts, mainly Northern California, Central California more protected. Hawaii overall looks pretty good. A modest to light trade wind pattern, a little bit of south winds, but nothing too bad. Let's take a quick look at snowfall and rain potential for California. So the pattern has been kind of weird lately. It has been sort of like La Nina in terms of north winds, not a lot of rain, but when there is rain, you get some snow. I don't really know where we are in terms of percentage of normal, but I'd say we're probably just a little bit behind normal for California in rainfall potential. Anyway, we get into Tuesday. Front moves into Northern California, a little bit of rain. Snow moving into the Sierra. Light snow, short-lived. By Wednesday morning, it clears out. Another rain system pushing into Northern California. Notice the focus is really Pacific Northwest, British Columbia sort of thing. The dividing line again appears, or the dry line appears to be right on San Francisco and Tahoe, something like that. Anyway, we get into Wednesday night. Thursday, pretty much dry. Friday, light precip moving its way into Northern California into Saturday. And then maybe, look at that, right on the San Francisco line as of Saturday morning. It continues. Little bit of snow forecast moving into the Tahoe region. Sunday morning, pretty firm snow indeed looking there. And rain down to Point Conception. Then high pressure sets up and things dry out. So let's take a look at snow, and really what we're looking at is not so much the details, but sort of where is the storm track going, where is most of the snow happening. So we'll just put this into motion. And you see, you get activity down into Tahoe, but the focus, again, really is up here. We'll just blast through this. This is a GFS model, 240 hours out, so that's like 10 days. You can just watch you can literally see it just streaming into the Pacific Northwest. For the most part, bypassing California, a little bit of activity every now and then. Here's the next weekend's forecast snow. Still, the focus up to the Pacific Northwest and really into like the Whistler and British Columbia area. And there we go, 240 hours out. Take a quick look at snowfall totals. This is over a 240-hour, 10-day range. But see, here's the snow projection for next weekend in this is Squaw Valley. Say a total accumulation of about 14 inches. Snow levels, you see, this is the base of the resort. This is the top of the resort. If it's red, it's liquid precip. You can see pretty warm, dipping down a little cold, warm. So kind of this, you get the sense the jet stream is north of the area. If the jet stream were south, then you'd have colder temperatures continuously. And wind, yeah, pretty much a normal wind pattern for the Squaw Valley area. Kirkwood, even less. It looks like about maybe 6 to 8 inches, something like that. Now, Kirkwood, by virtue of having a higher base, gets less, the temperatures are a little bit colder, but nothing particularly marked. And again, the wind levels, you see it. And Mammoth, because they are further south, almost nothing, maybe an inch or 2, 3 if you're lucky of total accumulation, but colder because the base is higher. Now, just for laughs, let's go take a look at Whistler. Whistler is right at the bullseye. Look at this total of, it's about 75, 76 inches of accumulation over the next 10 days. Base of the resort, pretty warm down low. Top, quite cool. So be high in the mountain there to get the best snow. Winds, not too much of a factor. Not bad at all. All right, let's go take a look long term. What's going on with the Madden-Julian oscillation and, of course, El Nino or La Nina or hanging just in the middle? We'll find out. So first off, the Mjo discussion. We're very interested in the status of the Mjo, as we said earlier, because so what is the Mjo? It's a periodic weather oscillation that traverses the equator the whole way around the planet. It moves from the active phase to the inactive phase. Like over the Pacific, it'll be active for 3 to 4 weeks, and then it'll switch to inactive for 3 to 4 weeks. Okay, it is only on the equator, 5 degrees north and south of the equator. When in the active state, it's basically like a area of low pressure. It tends to produce westerly winds or westerly wind anomalies. It tends to produce precipitation, and most importantly, it feeds energy into the jet stream. That, of course, then in turn feeds the storm track in winter months north of the equator, helps fuel storm development, which produces surf, and also helps to produce weather and rain and snow potential when it moves south of, let's say, the U.S. West Coast. All right, right now we're looking at data from the TAO buoy array, a series of buoys strung across the equatorial Pacific. Here's the East Pacific here, West Pacific here. The arrows are the wind speeds, and it's 5-day average winds. So we see winds strong out of the east in the East Pacific, fading to light over the central Pacific, and then building very strong out of the west. And this is actual wind speeds, and in what we call the Kelvin wave generation area, the area from 125, 135 east to about 170 west, 5 degrees north and south of the equator, right here. When the active phase moves over this area and produces west anomalies or west winds, that then has the potential to take warm water that's here, push it off to the east, not on the equator, but under the equator. It can traverse the whole width of the Pacific, then erupt off of Ecuador, forming a warm pool here. If you get successive Kelvin waves and they're strong enough, that can help fuel El Nino. All right, so obviously this is what we call the Kelvin wave generation area, because when you get west winds here, that's what makes Kelvin waves. West winds over here don't make Kelvin waves. It has to be in the far west Pacific. All right, so west winds in control. Certainly looks like the active phase of the Mjo. Anomalies, differences from normal for this time of year. Yeah, we have east winds. They're a little bit stronger. Just looking at the arrows, they're sort of blowing from the east. A little bit stronger than normal. That sort of looks like the inactive phase of the Mjo moving out. But you get into the Kelvin wave generation area, roughly right in here, you see strong west anomalies just blowing really hard, especially south of the equator, looking, again, like the active phase of the Mjo. So what's the forecast for the next week? Well, okay, so this chart, we've seen it before. This is the whole planet on one chart. The date line runs right up the middle. So the Pacific Ocean starts right around here and goes at like 130 east and goes to about 80 west, so somewhere about here. So that's the whole Pacific, but we're interested in the Kelvin wave generation area, 135 east to 170 west, so there to there, and you go straight up the chart. So this is the current forecast, today's date, okay? The Kelvin wave generation area then would be from here to here on the chart, and what we see is strong, the reds and the oranges, or the purples, are westerly anomalies. So we see strong westerly anomalies in the Kelvin wave generation area. And you can go back in time. You see we had sort of a westerly wind burst back here in December. Then we got into, we'll call it the inactive phase of the Mjo. Not so strong over the Kelvin wave generation area, but it's been set up here in the East Pacific. Very strong easterly anomalies in control until today. And it looks like they're fading out. And that's what would contribute to high pressure buildup off the California coast, splitting of the jet stream along California. All right, so the forecast looks like westerly anomalies, pretty solid indeed, holding for the next week. No, these easterly anomalies, the West Pacific starts right about there, so we'll say no easterly anomalies in the Pacific of any magnitude at all for the foreseeable future. That is good news. Well, let's go a little further into the future. 2 weeks out, this is outgoing long-wave radiation, basically fancy word for cloud cover. Remember, the Mjo in the active state is basically like low pressure tracking east on the equator. So blues are negative anomalies, meaning less sunlight reflectivity off the ocean surface, meaning more cloud cover, meaning the active phase of the Mjo. Active phase over the Kelvin wave generation area. Remember, Kelvin wave generation area, basically right in that area right there. And it is the active phase is basically supposed to hold 2 weeks out, but notice the inactive phase in the Indian Ocean building into the West Pacific 2 weeks out. So by then our active phase is supposed to start fading. This per the statistic model. The dynamic model, showing something similar. Active phase maybe making it to, here we go, maybe we'll say a week out, and then just fading to neutral. And then the dynamic model gets kind of confused. In fact, here's the statistic model. It seems normal that the inactive phase would follow the active phase, but this model, it doesn't quite have a handle on what's going on. So for now, we'll say active phase in control for at least the next week in the West Pacific. That should be feeding the jet stream and feeding the storm track. Next up, we take a look at phase diagrams. So what is this chart? Assume you're looking, this circle is, let's assume you're looking down on the North Pole, and we're looking at the equator. The Mjo moves from west to east, from the Indian Ocean over the maritime continent, over the West Pacific, East Pacific, under the United States, across the Atlantic, across North Africa, back to the Indian Ocean. And it just goes round and round and round. The heavy dot is where the active phase of the Mjo is. And the further away from this circle it is, the stronger it is. So the active phase, moderately strong over the West Pacific today. Over the next 2 weeks, according to the statistic model, it's to move over North Africa. According to the dynamic model, though, remember how the dynamic model in the last charts was kind of weird? It's like the active phase was supposed to redevelop in the West Pacific. Well, that's exactly what it's showing. Moderate strength active phase, instead of going around the planet, basically doubles back, retrogrades, and sets up somewhere in the far east maritime continent, the far West Pacific, and very weak. So a little bit of disagreement amongst the models long term what's going to happen. We'll favor the statistical for right now. We'll see how it plays out, of course. Here's the 40-day upper level model. This is like a jet stream level model. It's showing you areas favorable for precipitation. The green, favorable for precipitation. The red, not favorable. Basically, loosely interpreted, active phase, inactive phase. And this is a statistical model, and it runs about a week ahead of what it goes on down at the surface. So it's suggesting the active phase already in the East Pacific and moving out. It moves out over Central America by about February 4th. So it's really about a week behind that. So we have till about February 11th, something like that. Anyway, inactive phase sets up in the West Pacific on the 25th of January. It makes its move across the Pacific into, we'll say, mid to late February. And then another weaker, less coherent active phase sets up in the early part of we'll say mid-February, moving across the Pacific. And then there is the CFS model. Maybe not quite as accurate short term, but good at long term sort of general trends. Anyway, all right, so what are we looking at? Whole planet on one chart again. The West Pacific here, the Kelvin wave generation from here to here, West Pacific there, and East Pacific over right about here. All right, what do we have? The solid contour is the active phase, the MJO. The deep reds are strong west anomalies in control, forecast in the Kelvin wave, and forecast to hold into about, we'll say, somewhere around very early February, late January, something like that. Then the active phase disappears, maybe a very weak inactive phase. I mean, that's tiny, that's nothing. But west anomalies holding solid into mid-February at least. As long as you have west anomalies, that almost matters more than the actual active-inactive pattern, right? And what we see is a dead neutral pattern, if anything else. Oh, this is interesting. The low pass filter. We've talked about this before. This has a 3 contour line, sort of a pulse of low pressure building on the date line, sort of like a mini El Nino, but we're not going to call it that. Just sort of a low pressure bias building in January on the dateline region, helping to feed these westerly anomalies. This is a great pattern right now. This is good. We couldn't ask for anything better. And then, of course, the 3-month CFS model. This goes out 3 months now. Do you believe that? Of course not. But it gives you a general idea, sort of a trend of what's coming. And this is, again, the whole planet on one chart. West Pacific here, East Pacific over here. Kelvin wave between these two tick marks, just going straight up. Past performance, here's today's date, January 20th. Strong west anomalies in control of the Kelvin wave generation area. They're supposed to fade some now. But still, look at this, another big batch of pretty solid westerly anomalies forecast mid-February into the end of March. Pretty much continuously looking like the active phase. In fact, let's overlay the MJO. Here we go. Here's our active phase holding into, we'll say, the beginning of February. It backs off. Yes, I guess you could call that kind of an inactive phase. But before you know it, the active phase returns by Valentine's Day, holding well into March or so. And then supposedly the inactive phase sets up, but westerly anomalies in control that whole time. So generally a favorable pattern as we get almost the whole way through March. We'll overlay the low pass filter. 2 contour lines continuing. This is interesting. So the models had been continuously showing the second contour line like fading out, dissipating, like we're talking a month, 2 months ago, like in maybe the February or March time frame. And then all of a sudden, boom, we got this little baby third contour line that showed up in early January. And now 2 contour lines to hold solid the whole way through April. This looks favorable. This sort of bodes well for a year from now, next fall into winter, if this pattern holds. And of course, that's a wild guess that it would. But in general, things looking good, at least for the short term, and maybe the longer term as well. All right, enough discussion of the MJO. Let's go talk now longer term. El Nino, La Nina. First clue of what's going on as we look in the ocean. We're kind of looking for Kelvin waves, but remember, if you get enough Kelvin waves, that sort of gives you a hint of whether we're moving towards an El Nino sort of pattern. All right, so what do we have? This is the West Pacific here, East Pacific here. These are anchor lines on the TAO buoy array. This is the buoys strung across the equator on the Pacific, the whole way across the Pacific. The X's are the sensors on the anchor lines. You take the data from those sensors, you stitch it together with a model, and you get a subsurface water temperature profile in centigrade. So we see a little tiny ball of 30 degrees centigrade temperatures here. That's pretty warm. It was actually bigger last week, and I think bigger the week before that. It's significantly retrograded, which is kind of interesting. The 29-degree isotherm was at 170. It's backtracking to almost 173, 174 west. 28-degree isotherm, it was at 160. We're back to 164. So it looks like warm water here is retreating backwards. If you had a Kelvin wave, it would be pushing forwards. Okay, 24-degree isotherm, it was pushing into Ecuador. It's backing off as well. Let's go look at anomalies, differences from normal for this time of year. Well, we see quite warm temperatures, not incredibly warm, but warm anomalies under the dateline region. This looks like a Kelvin wave pushing east. We know we've got strong west anomalies here, and we had strong west anomalies associated with another active phase of the MJO in December. That's what created these warm anomalies here. That only looks like it's going to be fed by the current Kelvin wave that's pushing over the dateline right now. And we have a stream of 1 to 2 degree centigrade anomalies pushing the whole way into Ecuador. Now, we know we have some east anomalies going on over here, too, in the far east equatorial Pacific, associated with the inactive phase of the MJO that's moving over that region now. And that's probably what's making this, they're just neutral, normal right now, a little pocket of not cool anomalies, but not warm anomalies either. All right, let's move on. Here's another model using the same raw data, and it shows, again, warm anomalies streaming off the maritime continent, pushing over the dateline. What's that? 1, 2, 3, 4. 1, 2, 3, 4. So say 2.5, 3 degrees above normal. Notice just a little bit of cooling here. That wasn't there before, not as strong as it is now. We'll keep our eye on that. But anyway, you see the same pattern. Warm water falling over the date lines right there, so into the central Pacific, and then pushing up. This is what we call Kelvin wave number 6 in the series, and really warm anomalies pushing into Ecuador still as of January 13th. That is the remnants of Kelvin wave number 5, and generally warm temperatures filling 150 meters on up over the entire equatorial Pacific. That's warm. That's not cold. This is not La Nina. It's not really El Nino either, but it's, a lot better than any form of La Nina. All right, sea level anomalies. So this is another way to just sort of confirm what's going on subsurface. Warm water at depth expands. When it expands, it creates a bulge on the ocean surface. So we can use JSON-3 satellite data, strip out the wave height, strip out the wind waves, strip out the tide, and see if there's a bulge somewhere on the equator, 5 degrees north and south of the equator. And we see it, not huge, 0 to 5 centimeters above normal, extending from about 160 east the whole way to 100 west. That suggests warm water in this area. Also notice this little pattern here along Peru and Ecuador too. We think this is Kelvin wave number 5 impacting the coast there. This is broad Kelvin wave number 6 here. It takes 3 months from warm water here to make it into Peru for a Kelvin wave to traverse east across the Pacific. So we have at least 3 months of warm water in the pipeline, and possibly more now with these westerly wind bursts that's currently occurring over the far west Pacific. So a pretty good pattern. A warm water stream continuously being fed for months now. Not a bad looking setup. In fact, here's sort of the histogram, the past history. West Pacific here, East Pacific here. Here's the dates. The reds are warm water. Back in, we'll say, January of 2019, you can see a Kelvin wave built from a westerly wind burst. Pretty solid one. pushed across the Pacific, made its way into Ecuador in the we'll say the May time frame. Then last summer we had this weird kind of pattern where we had 2 Kelvin waves. They made it to the dateline Central Pacific and they just stalled while we had easterly anomalies and cool water building off of Central America. We were thinking, gosh, maybe we're moving towards La Nina. But the CFS model said, no, that's not going to happen. Temperatures are going to warm up. And we were like, hey, we think we're moving towards La Nina. Sure, it smells like it. But sure enough, boom, we got into the fall. Another Kelvin wave, active phase of the MJO set up. Here was our warm water. It pushed the whole way across the Pacific. This is Kelvin wave number 5, currently pushing into Ecuador today. You can see it there. This is Kelvin wave number 6 right here. It actually started, look at this, in November. And there's actually 3 different westerly wind bursts associated with it. We know there was one in November, another one in early December, and now there's one in early January, all helping to feed this Kelvin wave make its way across the Pacific. All right, sea surface temperatures. What's going on? We see warming off of Peru. It's interesting. We see cooling along the immediate coast of Peru up into Ecuador, but we see warming further off the coast. So this cool line, you can see it extends the whole way on the equator. We think this is being driven by easterly anomalies and the inactive phase of the MJO that's over the East Pacific right now. That said, there's a Kelvin wave hitting and it's producing warming off the coast, just off the immediate coast, and surrounding that cool stream. A warm water, very weakly warm, down to 10 south. It's this cool pool down here that's been in place for I think it started last summer and is continuing to hold now, sort of preventing the Kelvin waves from being as strong as we think they could and from impacting Ecuador as strong as one would hope for. But still, general warming in control. Sea surface temperature trend for the past 7 days. There's good news here. Last week we had cooling here midweek. There's this big finger, not big, but thin, pretty solid finger of cooling temperatures right here on the equator, again associated with the inactive phase moving over there. That is fading out significantly. We just have weak warming off of Peru now, and no real strong warming pattern, but no real strong cooling pattern in play. We suspect that'll change in the weeks ahead, and we think warming is going to be building over in this area as the active phase moves over here. And of course, actual sea surface temperature anomalies. Here's the last little bits of that cooling stream that we talked about earlier. It's there, but it's fading. Here's that cool pocket that has just persisted for months now off of South America. Here's our general warming trend over the eastern Pacific and then stronger in the West Pacific. The official El Nino monitoring region, the area called Nino 3.4, is 5 degrees north and south of the equator from 120 west to 170 west right in here. So when you see warm temperatures there, that's good. And we see a generalized warming pattern. This is the Nino 1.2 region, very noisy. Just sort of gives you a hint of what's going on in the East Pacific. We use this more for determining how much rainfall you're going to get in California. And because of this cool temperatures here and this just kind of not really warm, we've been sort of saying, yeah, we'll probably eke out a normal precip snowfall pattern for California for this year, but it really looked like La Nina earlier in the year. And again, we sort of focused on the snowfall track in January is heading up into British Columbia. We still think that's going to be the case most of the winter. We don't see any reason why the core of the jet stream would dip further south strongly. So yeah, we'll get snow in California, but at best normal. If you're looking for big dumps, head north, and that's where you'll find your powder. Here is the sea surface temperatures and the trend in the Nino 1.2 region, that area right there along Peru and Central America. And temperatures today, minus a quarter of a degree, 0.256 below normal. The trend, temperatures holding generally, we'll say neutral since November, but prior to that, back in the summer, temperatures really cold, not cold, well, they were pretty cold, yeah. And they've made it to neutral, but nothing more than that. In the Nino 3.4 region, the official El Nino monitoring region, temperatures today quarter degree above normal, 0.286, but the trend has been generally warmer than normal for, well, the past since October, hovering, if you were to eyeball, say 2 to maybe 2.5, a quarter degree above normal over the entire duration. So El Nino, you need to be half a degree, so you'd have to be up here for 5 consecutive months. That's not been the case. So we're basically above normal, but not enough to declare El Nino, just sort of a generally lightly warmer than normal in the Nino 3.4 region, which is more to the west. We've become way more interested in the Nino 1.2 region over the past 2 years, just in terms of, because that seems to affect California weather, U.S. West Coast weather, and also gives you a sense of how, if the jet stream's consolidated during the active phase, how far is that consolidated jet going to penetrate into the Gulf of Alaska? And if you have warm water in the Nino 1.2 region, that allows the consolidated jet to make it deeper into the Gulf, and that therefore brings storms closer to Hawaii and California, and therefore bring more swell energy into the coast of those locations. This is all good and fine. So we've talked about the MJO, we've talked about sea subsurface ocean temperatures, surface temperatures, but the real effect is, what does all this do in terms of the atmosphere? We're interested in storms, right? Storms produce surf, storms produce snow. If you don't have storms, you don't have either. All right, so what has been the contribution of all these patterns on what the atmosphere above the Pacific thinks is going on? Like El Nino. During El Nino, of course, most folks now know that when you're in a pretty solid El Nino pattern, that's like a long-running active phase of the MJO. It feeds the jet stream, it feeds the storm track. And likewise, when you're in La Nina in the Pacific, the exact opposite true. It's high pressure in control, a lot of wind, sort of like a long-running inactive phase of the MJO, like what we were in we'll say the early part of January. All right, so differences in pressure between Tahiti and Darwin. When pressure is lower than normal over Tahiti and stronger over Darwin, that looks like the active phase of the MJO. Today, the daily and so the index would be negative. Okay, today's daily contribution 2.93, which seems kind of crazy because we know the active phase of the MJO is in control, but for whatever reason, it's slightly positive. You can see it was negative starting in January 13th. 1, 2, 3, 4, 5, 6 days in a row. Now we're positive. We expect this to fall back negative. But anyway, this is kind of a noisy number. The 30-day average, better for looking at the phase of the MJO. Today we're at minus 4.70, but that's actually more positive than what it's been back in earlier in January. So not suggesting the MJO is particularly having an effect yet. In fact, we look back a month and it's 4.77 and went down to as low as minus 8 in early January from the active phase. Then we suspect this guy will start dropping, but we need to see the daily contribution fade more too. 90-day average, sort of your El Nino indicator, minus 6.36, needs to be down about minus 15 to be El Nino. We're not in El Nino, we know that. And looking back the past month, it's been holding rock solid right around the minus 6 range. Okay, so that's where we are. Not El Nino, certainly not La Nina, we're not positive, but sort of neutral biased El Nino-ish. Then finally, the long-term trend from the CFS version 2 model for the Nino 3.4 region, sea surface temperature anomalies. So this is sea surface temperature anomalies in the Nino 3.4 region, the official El Nino monitoring region. The solid line is actuals, daily analysis. As of early January, the thought was temperatures were, about 0.7 above normal. We know that's a little bit on the high side. We think it's more like about 0.3. But anyway, and that's supposed to hold into the early part of February. And then the model shows temperatures falling to neutral by about May, and then going negative into La Nina territory in October. Now, this is interesting because this one model says this, but other models are saying, no, we're just going to move down to like dead neutral into next fall. So we're not in the spring unpredictability barrier yet. I think that starts somewhere in the March timeframe and goes out till the end of May, where the models have a real hard time getting a sense of what's going on. And we don't see any clear signs of El Nino developing, but we don't see any clear signs of La Nina developing either. So we think this is probably a little bit extreme. Temperatures, we're thinking more in the neutral, bias a little high or low either way. Won't make much of a difference. So too early to know, but we'll take the warm temperatures, basically a good setup for the rest of the winter. All right, so the trend right now, very positive. Active phase of the jet stream, westerly wind anomalies in control of the Kelvin wave generation area, and forecast to hold for the next month. The idea is, or the thought is, jet stream is going to be in control, storm track solid, continuing for the next month. Clearly, just looking at the models for the next week, storm after storm after storm forecast. Some not particularly so strong, but a non-stop flow of waves. If you want to surf, we would suggest you make the time and go surf now. Now, the effect on snow, not so positive, not bad, but the storm track still pretty much aimed up to the north. Yes, occasional snow into the Tahoe regions. The further north you go, the more snow you get, especially along the coastal mountain ranges. That seems to be the thing. The jet is not pushing well into the interior Pacific Northwest. Yes, there's snow, but no big dumps. So if you're planning a trip, choose your location carefully. Longer term beyond that, MJO supposed to fade out as we get into February, but even looking beyond that, pretty much good until March or so, late March. So a pretty active pattern seems likely. Beyond that, are we going to El Nino or La Nina? No, definitely not. Certainly not El Nino. Probably not La Nina. Probably a neutral pattern long term, but it's way too early to know. We need to get into April or May before we can make any predictions about next winter. But for now, things looking very good, so make the most of it. Hey, if you enjoyed the video, give us a thumbs up. If you have any comments, for sure, comment in the comment section. We'll reply. We get some pretty good discussions going from time to time, picking on the finer details of the weather and some of the theoretical aspects and new breaking things in terms of long-term forecasting. Always an interesting discussion. And if you haven't subscribed, there's an option to subscribe down in the lower right. Just go ahead, give your email address. You'll get a notification when we update the video forecast. And with that, we're done. Whether we're going to do the forecast next Sunday, a little bit up in the air. Maybe we'll try to get it early. Hard to tell. Since there is weather, we are chasing it. So that makes our forecast, our personal forecast, a little bit less predictable. But anyway, thanks for watching. We'll do it again as soon as possible.